Okay, so I'm traveling right now, and so the quality of this video is going to be poor. My wife is driving, I'm not the one driving, but so you can hear road noise and such, but I just checked the progress of the class on my iPad, and I saw that, can you see this in attempted not yet learned panel, that there's 3 students that have worked on this topic but unsuccessfully, haven't completed it yet. So I want to do a quick video on this, and the quality is going to be low, but hopefully it'll be helpful. And of course, if you have other questions, I hope you'll ask me that also. I'm going to click on that one, and okay, all right. So it looks like I'm supposed to identify acidic and basic sites. No big deal. And it looks like the red is going to be the acidic, and I'm going to be working with the molecule on the left. You know what I'm going to do? I'm going to snapshot this, and I'm going to put it on my whiteboard. This is going to take a second, and it's a little clumsy, but I'm traveling, and I don't really care if it's that good. Okay, so all right, let's look at this. This is my whiteboard, and the left molecule, we're going to be doing the acids, and the right molecule, we're going to be doing the bases. Okay. Now let's go back to class for a second. Remember that bases are molecules that have the ability to take a proton from something else, right? And that's what a base is. And that's always going to be done with a lone pair of electrons. Always, 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 okay? So if I get my eyes used to looking for lone pairs of electrons, then it's a huge leg up, okay? So there's a lone pair, right? There's a lone pair, there's a lone pair, there's a lone pair, because remember we did this in class? All oxygens want to have 2 bonds and 2 lone pairs of electrons. Nitrogen, there's a lone pair, right? Because those are in the, because sulfur's in the same group as oxygen. Okay, so let's get rid of that. All right, now in an acid, that's what a base is. All right, so an acid is something that is a hydrogen that's bonded to an electronegative element, so that the electronegative element can take the electrons when the H plus leaves, right? And remember, this you got in your Chem 2 class. When I say electronegative element, I mean nitrogen, oxygen, or fluorine. Okay? Now, there's other electronegative elements, of course, but those are the big 3. Let me say, I see this sulfur down here. ALEKS is going to add sulfur on there. All right, but we're really definitely looking for nitrogen, oxygen, and fluorine. But since I see sulfur there, I don't think there's any others, too. You'll have to try this. Get it wrong a couple times. I think we're only going to be dealing with nitrogen, oxygen, fluorine, and sulfur, I think. All right, so do a couple examples yourself, and we'll figure it out. All right, so I see a sulfur here with a hydrogen on it. I see an oxygen with a hydrogen on it. Those are going to be my acidic sites. Now let's look at the basic sites. The basic sites are going to have lone pairs of electrons. There's some lone pairs. Oops, let's do that in blue. There's some lone pairs. You don't see them, right? But you practice enough, you get to see them, right? Those all have lone pairs. Okay, so those are going to be my sites. Let's go back over to the window. Acid is going to be, there's a hydrogen bound to electronegative element, so is there. Okay, and the basic sites are going to be anything with a lone pair of electrons if it's an electronegative element. Boom, 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 and boom. I think that's it. Okay, let's try one more. And I'm looking for hydrogen for the right side. I'm looking for hydrogen that's bonded to an electronegative element. I see one there. See the OH? Am I going too fast? And on the left, I'm sorry, that was the left side. On the right side, I'm looking for a lone pair of electrons on an electronegative element, and they're there. Now, chlorine has lone pairs of electrons, but I'm pretty sure it's not going to be considered an electronegative element here, so I'm going to leave it off. All right? And we were correct. Okay, let's just try one more. I'm looking on the left side. I'm looking for a hydrogen bonded to an electronegative element. I see it there. And here's one. This nitrogen doesn't have any. Okay, let's do the bases now. Lone pairs of electrons. Aha, I see one there. I see one there. There's one over here, but I'm not going to do that one because it's already got a hydrogen on it. Let's get rid of that. I think that's not going to be one. It's already got, there's no way it's going to take 2 hydrogens. Let's check that. And we were right. Okay. That's a short video. Again, the big deal was, let me go back to the whiteboard. The big deal was we're looking for the acid. For the left side, we're looking for a hydrogen bonded to an electronegative element. And for the base, we're looking for a lone pair of electrons that can go and steal a proton from some other place. And the exception to that was if you have a hydrogen that already it's got a lone pair, but if it already has a plus charge on it, not a good base. All right, I guess one other exception was chlorine was something that had lone pairs of electrons on it, right? But it's not electronegative, at least in the sense, not enough to be a good base. All right, hope that's helpful. Let's get back over here. Hopefully I recorded that. And don't you dare complain about the quality of this video. I know it's bad. All right, good luck.